Hello, I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get into medical school and other professional programs. And hello again to all you future doctors and medical professionals. Today on MCAT Bites, we're diving deep into the world of thermodynamics, focusing on a concept that's pivotal for both the MCAT and your future medical careers, enthalpy. This session is designed to enhance your understanding of enthalpy, complete with detailed explanations and a couple of example problems to test your knowledge. So stay tuned to the end to see how well you know it, or skip to the end to see if you need to watch this video. First, let's start with an introduction. What the heck is enthalpy? Enthalpy is represented by the symbol H. Makes sense, doesn't it? It's a measure of the total energy of a thermodynamic system. It includes the internal energy, which is the energy required to create a system, and the energy required to make room for it by displacing its environment and establishing its volume and pressure, PV. Enthalpy is a state function, meaning it depends only on the state of the system and not how it reached that state. This concept is crucial in understanding that heat transfer and chemical reactions, especially those occurring in the human body and the environment. For the realm of the MCAT, you're likely to encounter enthalpy in the context of chemical reactions and phase changes. A grasp of this topic lays the groundwork for understanding more complex thermodynamic processes and their applications in medicine, such as in metabolic pathways and drug synthesis. So let's understand heat capacity and specific heat. These are two fundamental concepts related to enthalpy. Heat capacity is the amount of heat required to change a system's temperature by a certain amount. It's a bulk property, meaning it depends on the amount of substance in the system. On the other hand, specific heat is a more useful concept when dealing with chemical reactions and phase changes on the MCAT. It's defined by the amount of heat per unit mass required to raise the temperature of a substance by 1 degree Celsius. The number you are expected to memorize for the MCAT is waters, which is 4.184 joules per gram Celsius. You can just remember this as 4. The specific heat of water, for example, plays a significant role in pretty much every biological process and is crucial for maintaining homeostasis in living organisms. If you haven't checked out our video on homeostasis and temperature regulation, please check that out. Understanding how specific heat and heat capacity influence energy changes in a chemical reaction is essential for predicting reaction behavior under different conditions. So let's take a look at enthalpy changes. Again, what we've established, this is delta H, or H. Delta just means change. It indicates the amount of heat absorbed or released during a chemical reaction at a constant pressure. A negative delta H would be an exothermic reaction. It means heat is released into the surroundings. Where a positive delta H, an endothermic reaction, indicates heat absorption. This concept is vital for understanding how energy transformation in chemical reactions can influence the environment, such as the combustion of fuels or metabolic processes in the human body. It's also good to know that if the reactants are losing energy to become products, it's probably, you don't have to add energy to the reaction. Whereas if the reactants are low energy and the products are high energy, it means we have to add energy somewhere, probably from ATP if we're talking biology. A fascinating application of enthalpy in the medical field is in pharmacology, where the enthalpy of a reaction plays a role in drug design and synthesis. The efficacy and efficiency of drug interactions and the body's metabolic reaction to drug compounds can be optimized by understanding the enthalpy changes involved. So this is just another way to show what I was talking about before. Endothermic means we are gaining heat surroundings. Our system is getting more energy. Whereas exothermic, we are giving it up. Our system is losing energy. It's going into the outside, into the universe. Now let's do some practice problems to really nail this home. Consider the reaction of zinc with hydrochloric acid to produce zinc chloride and hydrogen gas. The enthalpy change for this reaction is delta H equals negative 153 kilojoules. What type of reaction would this be? Endothermic or exothermic? Well, in this case, it would be exothermic because it means that 153 kilojoules of heat is released to the surroundings. As you continue to prepare for the MCAT, pay special attention to enthalpy. It'll save you a lot of points on the Chem Phys and biochem sections. Thank you so much for watching our video on enthalpy, and I'll see you next time.